Hello, this is the section 8.5 lesson. In section 8.1 we introduced the idea of common factors and common multiples. In this section we're going to introduce the idea of greatest common factors and least common multiples. And we'll talk about how to find greatest common factors and least common multiples. And then we'll also solve a word problem involving these ideas to illustrate why these ideas are important. So let's start off with the definition of a greatest common factor. The greatest common factor of two numbers is the largest number that divides both numbers. So notice that we need to start off with two numbers, and we're looking for the largest number that divides both of them. So as an example, let's find the greatest common factor of 12 and 18. Well, one approach to do this is to just list all the factors of 12 and 18. And we talked about how to do this in section 8.1, so we won't go through the steps there. But here are all the factors of 12, 1, 2, 3, 4, 6, and 12. Likewise, there's all the factors of 18. And so notice that we have some common factors here. Like 1 is a common factor, 2 is a common factor, 3 is another one. But the largest of these common factors we see is 6. And so there's our answer. The greatest common factor of these two numbers is equal to 6. The next definition is the least common multiple of two numbers is the smallest number that is a multiple of both numbers. So we're going to start off with two numbers, and we want to find the smallest number that is a multiple of both of those numbers. So let's illustrate this with a simple example of finding the least common multiple of the numbers 12 and 18. Well, one way to do this is to simply list a few of the multiples of 12 and 18 and look for common multiples. So section 8.1 we talked about how to find multiples of numbers. And so here's a few multiples of 12. 12 times 1 is 12, 12 times 2 is 24, 36, 48, 60, so on and so forth. We could keep going forever. The multiples of 18, 18, 36, 54, so on and so forth. And so what we want to look for is the smallest number that is common to both of these lists. And we see that the smallest of those numbers is 36. And so there's our least common multiple, equals 36. Now, these methods for finding greatest common factor and least common multiple are fine for small numbers. They're not going to work very well for large numbers, but here in a bit we'll talk about a more efficient way of finding greatest common factor and least common multiple for larger numbers. But first, let's look at an example of a word problem that would require us to find a least common multiple or a greatest common factor. So here's the scenario. You want to make identical goodie bags with pencils and stickers, but you only have 12 pencils and 18 stickers. The question is, what's the largest number of goodie bags you can make? So we want the goodie bags to be identical, which means that they need to all have the same number of pencils. They each need to have the same number of stickers. And we want to figure out what's the largest number of goodie bags you can make. Well, let's just start off with a for instance. We could, for instance, make 2 goodie bags. If we made 2 goodie bags, we'd put 6 pencils in each bag and 9 stickers. That would use all 12 pencils and all 9 stickers. So it's possible to make 2 goodie bags. Another for instance, we could make 3 goodie bags. If we made 3 goodie bags, we'd put 4 pencils in each bag and 6 stickers in each bag. So we'd use all 12 pencils, all 18 stickers. So there's another possible answer. Maybe 3 is the maximum number. So we know we can make 2 goodie bags. We know we could make 3 goodie bags. Maybe we could make 4 bags, maybe 5, maybe 6, maybe 7. Of course, the maximum number, absolute max, would be 12, but just the correct answer. So let's make an observation here. In the scenario where we made 3 goodie bags, we could think of each of these bags as a group, and in each one of these groups we have 4 pencils. So we have 3 groups. Each group contains 4 pencils. 3 times 4 is equal to 12. Well, what's significant about that? Well, again, 3 is the number of goodie bags, 4 is the number of pencils in each bag. So what we showed there is that the number of bags that we make times the number of pencils in each bag has to equal 12, which is the total number of pencils. Likewise, in each of these bags we have 6 stickers. So 3 bags or 3 groups times 6 stickers in each bag equals 18, which is our total number of stickers. So again, we see that the number of bags times the number of stickers in each bag has to equal 18, our total number of stickers. Well, now let's take a step back and make an observation. We showed that the number of bags times some whole number has to equal 12. Likewise, the number of bags times some whole number has to equal 18. So, in other words, the number of bags is a common factor of both 12 and 18. So the question is, what's the largest number of bags we could make? Well, the largest number of bags is going to have to be the greatest common factor of the numbers 12 and 18. So this problem in the end boiled down to finding the greatest common factor. Well, we already found that greatest common factor in the previous example. That greatest common factor was equal to 6. So there's our answer. We can make a maximum of 6 bags. So in our last example, we are going to use a method that the book calls the slide method to find the greatest common factor of 2 large numbers. Now these numbers are rather large, and if we tried to list all of the factors of these numbers, that would maybe take a while, and so that wouldn't be a very efficient way to do it. But we can do this rather efficiently using this so-called slide method. We're not going to talk about why this works, we're just going to simply talk about how it works. So we're going to start off by making a table like we see here. In the top row we're going to leave a blank here, and then we're going to put our first number here and then our second number here. Okay. Now in this blank here on the left, we are going to put a common factor of these 2 numbers. Now we can start off with any common factor that we want. Well, we note that both these numbers end in 0, and so a common factor is 10. So let's write that common factor there. And now in the next row, we are going to divide both of those original numbers by 10 and write the results here. So 108 and 120. Now in this cell here, we are going to put a common factor of this number and this number. And it can be any common factor. Well, notice that both of these numbers are even, so they have a factor of 2. So if I divide 108 by 2, I get 54. And if we divide 120 by 2, we get 60. So now in this next blank, we're going to put a common factor of 54 and 60. Well, again, we note that both these numbers are even, so let's put a 2 here. 54 divided by 2 is 27. 60 divided by 2 is 30. And so we're going to keep going. In this cell here, we're going to put a common factor of 27 and 30. Well, notice that both of those are divisible by 3. So 27 divided by 3 is 9, and 30 divided by 3 is 10. And now we could keep going. In this cell we would put a common factor of 9 and 10, but 9 and 10 have no common factors, and so we're going to stop. Now, to get the greatest common factor, we are going to multiply these numbers here on the left-hand side. So our greatest common factor is going to be 10 times 2 times 2, I'm running out of room here, times 3. Okay. So 10 times 2 times 2 times 3, if we do that arithmetic, that comes out to be 120. So there's our greatest common factor. Now, to find the least common multiple, I'm going to multiply these numbers here on the left and these numbers down here at the bottom. So our least common multiple is going to be, well, the product of these numbers here on the left is equal to 120, And then we're going to multiply this by the numbers down here. So we're going to multiply this times 9 and then times 10. And if we do that arithmetic, we're going to get 10,800. You can verify this arithmetic on your own, but this is what it comes out to. So there's our least common multiple. So there's how to do the slide method to find the greatest common factor and the least common multiple. How it works is explained a little bit in the book, but that's how to do it.